Good morning students. Today I will teach class 9, chapter 9, that is force and laws of motion. In previous lecture we had studied about the force, the effect of force and the types of force. And also we had done about the Newton's first law of motion. In today's lecture I will discuss about the next laws of motion, that is second law of motion, third law of motion and the topic, that is momentum. So let's start with the second law of motion. So Newton's second law of motion states that rate of change of momentum is directly proportional to the unbalanced force that is applied on an object. What is that? Rate of change of momentum. That is rate of change of momentum is directly proportional to the force applied. So here, what is momentum? So momentum is the motion of the body. So we write momentum is the product of mass and velocity. So I will write the mathematical expression of second law of motion. So we will write that rate of change of momentum is directly proportional to the force. Or we can simply say that the mathematical expression of Newton's second law of motion. So here, mathematically, consider a body of mass m moving with velocity, that is initial velocity u, and the final velocity, that is v. So momentum. So here momentum is given by p. So momentum is mass multiplied by velocity. So mass is m and velocity is v. Clear? So here rate of change of momentum. Rate of change of momentum is change in momentum upon time. Change in momentum upon time taken. So change in momentum is, so first for initial velocity, that is momentum p2, and for final velocity momentum p1 is m into u. So what is change in momentum? So change in momentum is mv minus mu upon t. So as m is common for an object, so m take out common, that is v minus u upon t. So this is rate of change of momentum. Or we simply say that is dp by dt. What is dp by dt? dp by dt is change, small change in momentum upon small change in time. So firstly we can say that body is at rest. So it is the initial time and it is the final time. So t minus u is t. So rate of change of momentum is change in momentum upon time taken. So here you can easily see here. So according to second law of motion, that rate of change of momentum is directly proportional to the force. So what is the equation of motion? We already done in previous lectures of chapter 8. The equation of motion is v is equals to u plus at. So v is u plus at, that is v minus u upon t is a. This is equation number 1 and this is equation number 2. So from equation 1 and 2 we simply say that m is v minus u upon t, that is a, is equals to f, or we can say force is equals to m into a. Here, what is a? So force is equals to mass into acceleration. So this is the new term or the another term for Newton's second law of motion. So here the unit of force is, so that is SI unit of force is, that is 1 Newton. So we can say Newton, or we simply define what is 1 Newton. So 1 Newton is defined as, so 1 Newton is equals to 1 kg, that is for mass 1 kg, and acceleration is 1 meter per second square. So we can say that 1 Newton is equals to kg meter per second square. So here you can see the force is said to be 1 Newton when a body of mass 1 kg has acceleration of 1 meter per second square. This is all about the Newton's second law of motion. This is the another statement for Newton's second law of motion, and this is the original statement of Newton's second law of motion. So next is Newton's third law of motion. So what Newton's third law of motion says? It says that to every action there is equal and opposite reaction. What does it mean? If a body of mass A and body of mass B exert a reaction on A, then there is equal reaction is exerted by B on body A, but that reaction is in opposite direction. So here we can say that if FA, that is force applied by A on B, force applied by A on B is equal in magnitude, that is force applied by B to A, so that is in opposite direction. So negative sign indicates that if A applied force on B and similarly B applied force on A, then both the substance has equal force, but this force is in opposite direction. So this is the statement of Newton's third law of motion. To every action there is equal and opposite reaction. So next is momentum. So next topic is momentum. So as I already told you about momentum, momentum is nothing, it is the ease of motion, or we can simply say that it is the motion of an object. So it is denoted by P, as in Newton's second law of motion we already used that term P. So momentum P is product of mass and velocity. So P is equals to m into v. If the velocity of an object is 0, which means body is not moving at all, so that is v is 0, we can say that m multiplied by 0 is 0. So P is 0. So here we can say that a body is not moving at all. So if the velocity of an object is 0, then momentum is also 0. So next we will do the conservation of momentum. Conservation of momentum means if a body A is acted a force upon body B, then the total momentum of both the bodies before and after the collision remain conserved. So what is the conservation of momentum? If a body A and B has momentum before collision and the momentum after collision, the momentum initially or finally remain the same. So we can say that the conservation of momentum means initial momentum is equal to the final momentum. So we can say that initial momentum is equal to the final momentum. So here a body A and body B. The body A has mass m1 moving with velocity u, and the body B has mass m2 moving with velocity u2. Here we can use u1. It is before collision. Similarly, the body A and the body B having mass m1 and velocity v1, mass m2 and velocity v2, and collide with each other, that is after collision. So here we can say that if a body A of mass m1 and body B of mass m2 having velocities u1 and u2, similarly the body A and B after collision changes their velocity from u1 to v1 and u2 to v2 respectively. So due to change in velocity, there is a change in momentum. So we can say the change in momentum of A. So body A has momentum, that is m1 v1 minus m1 u1. So we know momentum is product of mass and velocity. So here it is m1 v1, that is final momentum, m1 u1, that is initial momentum. So change in momentum of B, so that is m2 v2 minus m2 u2. So take it as number 1 equation and take it as number 2 equation. So it is change in momentum. But according to Newton's second law of motion, that is rate of change of momentum of A. What is that? Rate of change of momentum means change in momentum upon time taken. So what is change in momentum? m1 v1 minus m1 u1 upon t. Rate of change of momentum of B, that is m2 v2 and m2 u2, that is upon t. But we know from Newton's third law of motion, to every action there is equal and opposite reaction. If the A applied the force to B and B applied the force to A, that force is opposite. So F1 is minus F2. What is F1? F1 is rate of change of momentum. So it is here m1 v1 minus u1 upon t. What is F2? Minus m2 v2 minus u2 upon t. So as it is same on both sides, we can cancel. So just multiply between the brackets, that is m1 v1 m1 u1. Here minus sign indicates m2 v2 and minus m2 u2. So just the simple simplification, minus side goes inside, m2 v2 minus minus plus, that is m2 u2. So just combine the v1 and u1 terms. That is M1 V1, V2 is come here, M2 V2, M2 U2, and here M1 U1. So it is M1 V1, that is the product of the final momentum of A, and the product of final momentum of B. We can say that it is the final momentum of A and B, which is equal to the initial momentum of A and B. So from this we conclude that the momentum of a body before and after the collision remain conserved. So this is the law of conservation of momentum. So with the completion of this topic, we had complete the chapter number 9 along with the syllabus of class 9. Thank you.